friends, in this video we are going to study one type of digital voltmeter which is known as the integrating type of digital voltmeter. Here we will study the construction, block diagram and working of the integrating digital voltmeter. So let us start with our topic. As we know that the digital voltmeters, they are used for the measurement of the potential difference between two points, or we can say that they measure the voltage. So digital voltmeters, they give us the digital output, or we can say the numerical value of the voltage which we want to measure. Now the digital voltmeters, they are of various types, like there are 5 types of digital voltmeters. One is the RAM type digital voltmeter, integrating type digital voltmeter, successive approximation type digital voltmeter, potentiometric type of digital voltmeter and continuous balance digital voltmeter. Here we are studying about the one type of digital voltmeter which is the integrating type of DVM or digital voltmeter. So let us start with it. This integrating type of digital voltmeter, it measures the average value of the input voltage over a period of time. Because here we are using the term integrating. So whenever this integration over a period of time is used, means we are measuring the area cover under that curve. Suppose that we are having a sinusoidal wave. So whenever we use the term integration, what does that means? That we are calculating the area of which is covered under this curve over a fixed period of time. So this integrating type of digital voltmeter, it also measures the true average value of the voltage over a period of time. Okay. So in this integrating type of digital voltmeter, it is going to use an integration technique which uses the voltage to frequency conversion. The voltage will be converted into frequency and frequency will be measured, and that the value of that frequency will be in proportion to the value of the input voltage. So here in this integrating type of digital voltmeter, an integration technique which uses a voltage to frequency conversion is employed. Okay. So this voltage to frequency converter which is used here, it is going to convert the input voltage into the frequency, and then the frequency will be measured. So frequency is proportional to the magnitude of the input voltage. So here for the voltage to frequency conversion, a converter is used, and this converter is going to function as a feedback control system, because this converter is going to control the rate of pulse generation, because that rate of pulse generation is in proportion to the magnitude of input voltage. So here we are having a converter which act as a feedback control system, and it controls the rate of pulse generation. The pulses will be generated in proportion to the magnitude of the input voltage. So if we are going to measure the rate at which the pulse are generated, we will be able to find out the magnitude of the input voltage. So what basically is done in this integrating type of digital voltmeter? A train of pulses is produced. A train of pulses is generated, and the rate at which these pulses are generated, that will be equal to the input voltage. Then these pulse of generated, then how many number of pulses are appearing in a definite interval of time or in a fixed period of time, that will be counted. So the number of pulses which are generated in a fixed period of time, that will be the frequency of the signal, and by calculating the frequency we are measuring the input voltage, because here the rate at which the pulses are generated, that will be in proportion to the input voltage, so their magnitude will be equal. So frequency of these pulses will be a function of an unknown voltage, and the number of pulses counted in a period of time, in that period of time, is an indication of the input voltage. So that is the basic principle on which this integrating type of digital voltmeter works. How it is converting a voltage into a frequency, and by measuring the frequency, it is by measuring the frequency, or we can say by measuring the number of pulses in a fixed period of time, it is measuring the input voltage. Now let us come to the block diagram of this integrating type of digital voltmeter. So this is the block diagram of the integrating type of digital voltmeter. You can see here the different components are an integrator, level detector. Here we are having a pulse generator gate. Then we are having a pulse generator, main gate is here, then counter, start stop gate, time base selector, clock oscillator, and the readout where we are getting the display of the input voltage. Now, the heart of this technique of this integrating type DVM is the operational amplifier, which is acting as the integrator. So, this integrator is the main part of the digital voltmeter. Now, here one the input of the integrator is the input voltage which we want to measure. So, the output of this integrator will be the voltage E, which is equal to minus of EI 1 by RC into T. Okay. So, if we see the output of the integrator, we can see that if a constant input voltage EI is applied, because R and C, these are the constants of the integrator, so the output voltage is produced at a uniform rate. Okay. If we are having also, here you can see that the polarity, because here we are having a negative sign, so there is a polarity difference between the input voltage and the output voltage. So if a constant input voltage is applied to the integrator, then the output of the integrator will be a voltage which is produced at a uniform rate and which is having a polarity opposite to the input voltage. Okay. Now here we can see that the magnitude of this input voltage and the output voltage, it will be equal. So as soon as here we are having the integrator, as soon as we are applying the input voltage EI, it is going to produce the output voltage E. So suppose that we are having the input voltage like, because here we have written that a constant input voltage is applied. So suppose that a 20 volts is applied. So when an input voltage, a constant input voltage is applied as an input to the integrator, the output of the integrator will be the voltage E. You can see that the polarity of this output voltage, it is opposite to that of the input voltage, and when this input voltage is constant, opposite voltage is in the negative side and it is increasing. Okay. So in this way, if the magnitude of input voltage is increased, this deflection of this output voltage will also be increased, its slope will also increase. So the magnitude of input voltage and output voltage, they will change accordingly. Okay. Now the slope of the output voltage, it is determined by the value of the input voltage. If the input voltage is more, then the slope will also be more. If the input voltage is having less magnitude, then the slope of the output voltage will also be less. So we can say that the output voltage, it is changing in proportion to the input voltage. Now again coming back to the block diagram, we have seen here that input voltage, when it is given to the integrator, it produces an output voltage E. Now this output voltage is given to the level detector. Now this level detector, it is going to detect the magnitude of the output voltage. Means when the output voltage, it reaches a fixed value, then this level detector, it is going to produce the output which is going to trigger this gate signal. Okay, so when this output has reached a value, this signal is generated, and the level detector, it gives a pulse to this pulse generator gate, and it is going to trigger this pulse generator, so that pulses will be generated in proportion to the input voltage. So this output voltage is given to the level detector. So you can see in the block diagram, input voltage applied to integrator, it will produce output voltage. When this output voltage reaches a reference level, the level detector is going to generate a pulse to the pulse generator gate. Now this level detector, it basically acts as a comparator. It is going to compare the value of the output voltage with a fixed value, and when these two values are equal, it is going to generate a pulse. So it basically acts as a comparator. Now, as I have said that the magnitude, or as I have said that the slope of the output voltage, it is in proportion to the value of the input voltage. So if the input voltage, it is having very greater value, then the slope of the output voltage will be more sharper, and more quickly it is going to reach the reference level. So quickly the pulse will be generated. The pulse is going to trigger the pulse generator. So depending upon the value of the input voltage, you can see that how fast the processing is done. So when this output of level trigger, the output of this level trigger is going to trigger this pulse generator gate. So this pulse generator gate will be open, and the clock oscillator, which is providing the clock pulses here, these clock pulses will be passed through this pulse generator. Now pulse generator, it is a Schmitt trigger which is produces an output pulse of fixed amplitude and width every time it receives the pulses. Okay, so every time this input voltage output voltage is going to be equal to the reference level, then this gate will be open and clock pulses will be passed through the pulse generator. So every time a pulse will be generated here which is of fixed amplitude and fixed width. So now comes the function of the pulse generator. Now this output pulse, it is of opposite polarity. We have seen that the output voltage is of opposite polarity with the input voltage. So output pulse, so here we have seen that the pulse rectangular pulse will be generated. Now this rectangular pulse is again fed back to the input of the integrator. Now this integrator, because we have seen here that when the output voltage is given to this integrator, the output voltage is equal to the level of that, so no more pulses from the clock oscillator, they are going to pass through the pulse generator. So this pulse generator will be stopped. Now this pulse is going to be passed through this main gate. Okay, after that it will be counted by the counter, and then the number of pulses which are passed for a fixed period of time, that will be displayed here over the display unit. So by reading the frequency, we are measuring the magnitude of the input voltage, because input voltage, it has been converted into output voltage, it has been converted into the pulses. So the number of pulses which have passed through a fixed period of time, that will be equal to the magnitude of the input voltage. So when the output voltage pulse from the pulse generator, it has passed, it is going to be restored its original value, and it starts rising again. Now the pulse generator, it is then triggered by a pulse from the clock or generator, and the entire cycle of the generation of the rectangular pulse, that will be repeated again. So in this way, the cycle is repeated, and whatever is the input voltage, according to that, the output pulses from the pulse generator, they will be generated. So the frequency of the wave, it is a function of the voltage being measured, because every time one pulse will be generated by this pulse generator, and this will be equal, this will be counted by the counter. So the every time the pulse will be generated when this input voltage magnitude is will be equal to the reference value. So one pulse is generated. One pulse from the pulse generator is produced for each cycle of the wave. So in this way, the number of pulses which are being generated in a fixed period of time, that will be equal to the magnitude of the input voltage. So we can say that the number of pulses produced in a given period of time interval, which we call the frequency, is an indication of the voltage being measured. So in this way, the integrating type of digital voltmeter, it is integrating means over a period of time we are measuring the signal, okay? Average value of the voltage is being calculated. So this was the block diagram. We studied the explanation of all the parts, that what is the function of all the blocks in this DVM, and how this digital voltmeter measures the voltage by measuring the frequency or by measuring the number of pulses passing through a fixed period of time. So I hope that this topic, integrating type digital voltmeter, it is now clear to you. Thank you.